Hello everyone, I'm Sharon and welcome you back in this machine learning tutorial series. So in this video as well, we are continuing with the linear regression with the R language. So in this video, I am going to work with the linear regression. Now finally, we are all set to go with or to work on the linear regression. So now opening the R Studio. So I have done everything, like I have written the code or the commands, and I will be explaining each and every command one by one so that it will be easier for you to understand and you can implement it on your own, like by viewing the command that is from here also, that is on the history portion also, and from the console and terminal portion also. So as in the previous video, we actually have saw, like already worked with the uh, like train sets and training sets, and as we have divided the data sets into train set and test sets, and we also viewed the train sets and test sets. So now we are going to apply the linear regression. So for the linear regression, the function that we have used is lm, which take two parameters. The first one is depending on the dependent and independent variable, and second is the data that is going to model the that is actually going to train the model. Okay, this lm function is actually used to make the machine learn or from the different functionalities or like feature extraction, as we have already discussed in the first video as well, that as we always work on feature extraction, and according to the feature extraction we try to predict the something that is more similar to the thing that from where we have extracted the feature. Okay, so this lm function is basically used to uh, train the model, and here we have price as the dependent variable and caret as the independent variable. Okay, and as you can see in the diamond table as well, we have price and the caret. So and the data set that we are going to train the model is the train one, as we have already have extracted it from the with the help of like sample, split, and then subset functions. And I'm storing it in the link data sets, and whenever like I try to view the link, I wrote the command link here, as you can see, and as I call the command link, it generates like the intercepts. It gives the intercepts and the formulas that I have used. Intercept is basically like as we already know that linear regression follows the line equation, that is y is equal to mx plus c, and that c is here given as minus 2327, that is 2327. Okay, and after that now we try to predict it according to the test that we have tested, and I have used the predict function with link as the data set. That is, link is basically the trained model that we have, and the new data that we apply is test one. Okay, test one is our test set, and and we are storing the predicted values in link one. Okay, and again we view the link one and test one as well, and as we see the test one and link one, we can get the views on the price of the test one and link one. uh, the price will be like this one, that is predicted one and actual one. You can see in the diamonds, like in the test set the price is there, and similarly for the link one as well, it will be like for the link one as well, we have the price, and I have used the cbind function to create an object. So for the creating the object, I have used like we have to use two parameters, the actual one and the predicted one. The actual one, from the actual one I have extracted the price column, and from the predicted one, for the predicted one I have extracted the link one. Link one actually contain the price column only, and I have stored it in the final result. Okay, and I have written here wrong. So in the next command, I have wrote it correct, like test one, as you can see, because our test data set is in test one data sets only. And after that, after storing it into final result, I have tried to view it using the view command, that is view final result. And after that, we try to know the class of the final result. With the class of final result, we got to know that it is matrix. But as we know that we should work for with the data frames, so I tried to convert it into data frame. So as dot data dot frame is a command that is used to convert a matrix or array to a data frame, and the data set that we need to convert is final result, and again we are storing it into final result only. And then again we try to view the final result. The final result actually looks like this, and we try to view the class of the final result now, and it is showing data frame. Now again I tried to like find the residual, as we have seen in the previous videos that residual is the gap between that the difference between y naught minus yp, so yp square. So I have tried to extract the actual like a final like find from the final result I tried to extract the actual column, and from the final result I tried to extract the predicted one, and according to that I found the difference between them and I stored it in the residual. And after the residual, I again created an object with cbind function, and with the cbind function, I passed the two parameters, final result and residual, and I again stored it in the final result to get all the three quantities, that is actual, predicted, and residual. The difference between actual and predicted also in the same table. And again, I tried to calculate the y naught minus yp whole square value, and then I calculated it, and it shows the different for the different entries. You can see now. If we try to like then applying the actual formula, that is a square root mean final result, and we saw that the square root value, that is the actual value of m that we have, is 1418, and we are storing this value, that is this slope value, in a RMSE final file to compare it with the different uh, fit line, like good fit line, and according to that we will find the good fit line for us. And for that I will continue this in the next video. We will compare this one, that is RMS final square root mean value, and again in the next video we will again create another good fit line, and we will compare these two, and we will see which one is the best, and we will implement it in the linear regression. So in for this video, that's all. Thank you for patient hearing, and that's all. Stay blessed.